very first speaker today is Matteo. As I mentioned, he is the chief software architect at NearForm, where he consults some of the top brands in the world. In 2014, he defended his Ph.D. thesis titled Application Platforms for the Internet of Things. Matteo is also a member of the Node.js Technical Steering Committee, focusing on streams, diagnostics, and HTTP. Big shout out for the recent fetch release that I know that you were heavily involved in. He's also the author of the fast logger Pino and the Fastify web framework, and he's given talks at over 60 conferences, including Node.js Interactive, Node.js Conf, NodeSummit, JSConf.Asia, WebRebels, and JsDay, to name a few. He's also the co-author of a book, Node.js Cookbook, 3rd edition, and in the summer he loves sailing. The Sirocco, which I recently learned means the hot breeze coming from Africa towards Europe. So now, without any further delay, I bring you Matteo.
Hi folks, everyone. How are you doing? Hey, this time around, Daniel, you are the host and I am on the other side. You know, it was, we need to get to do this a few times over the years. So if for all of you, Daniel was part of the spoke at NodeConf.eu last year, so it was that type of dynamic. Anyway. I'm so happy to be here presenting this talk about GraphQL caching. It's a very interesting topic. So which I really like, and I've been researching and implementing for the last while. So it's really keen for this talk.
I'm really excited. So the stage is yours, Matteo. And to our viewers, we're going to be doing a short Q&A following the talk, so be sure to drop your questions in the chat.
Please do, okay? Please ask me questions. This is a meetup, it's live. I like live talks, even though they are remote, but I like live talks. Otherwise, I can just record this and you would play, and I prefer not to. So let's do it in a second. Something that Daniel did not say is that I also have my newsletter at nodeland.dev, and you can follow my newsletter. You can learn a few things about Node and stuff, what's happening in the Node community by it. So yeah, check it out. And of course, follow me on Twitter at Matteo Collina. You can see it in the overlay down here somewhere. There is an overlay. Hey, happy days. So first of all, this is a talk about magic. Okay, do you like magic? Well, I don't know. I was really fascinated by David Copperfield when I was a kid. Okay, and I don't know if you ever seen these fantastic show. This is in. I really wanted to attend one. Never attended one. Only watched on TV. So, but I find this quote that really resonate with me. So my job is to make people dream. Of course, there's a lot of technical stuff behind the scenes and a lot of hard work behind it. But I get to watch people see the result of that hard work and feel that wonder and feel that discovery all the time. This is more or less what I do. Okay, I tend to come up with some innovative way of implementing some code, and and people have that feeling of wonder and discovery that come from unveiling something new. So what magic I'm going to use today? I'm going to show you how to improve the performance of your GraphQL gateway by 4 times, at least, minimum 4 times, probably more. Okay. First of all, let's talk about the tools that we're going to use to make this magic. So first of all, we're going to use Fastify. This is a framework for, it's a web framework for Node.js. You should be using it if you want to write fast APIs. If you want your code to be fast, use Fastify. Okay. It's also full-featured. It has a router, a logger, a lot of other things. I have a lot of talks on Fastify, so look them up. Okay. So you should be able to get a lot of stuff, information of it. We also have a nice website, so hey, check it out. I'm sorry if you hear my daughter screaming from the outside. I'm so sorry if it passed through, but that's like remote life. The other thing that we are going to use today, the other tool that we have, it's something I've built in a few years back and kept maintaining and improving. It's a library called Mercurius. What does Mercurius do? Well, Mercurius, it's a GraphQL adapter for Fastify. Okay, and I have been, exploring with it, maintaining it. It works really well. In fact, it's actually very fast, several times faster already compared to the most widespread solution that you can use. So it's great. On top of that, it has two modes. It has a normal operation, but also it has a just-in-time compiler. So you can actually enable the JIT compiler, so that it actually it takes your query, GraphQL query, and it compiles it down to JavaScript before executing it in a safe way. It's great, works beautifully, and we have it in production. It's really like really fast. We're also going to use Autocannon. I don't know if you ever heard about this library, but it's a myload testing tool. I wrote it long ago, again, on the sofa. On the sofa of my previous house. So happy days. Now, let's talk a little bit about what we are going to optimize and what we are going to make it fast. So first of all, we are going to use two services that have been federated. So we have a user service and a post service that have been federated together. We are going to turn on and off our cache. And our target services serve data from memory. So there's no database involved. In fact, if there is a database involved, you probably see way more dramatic improvements. So this is one of the example services. So we have our users, our schema, our resolvers, very easy. We are enabling the JIT, and it's pretty normal. Okay, pretty normal stuff. So it's time for magic. Let's see if we can make something disappear. So this is our baseline. Okay, I've run some benchmarks, and this is our baseline. You can test it at home, by the way. All the code in here, it's available online, so you can check it. It's in the Mercurius cache repository. So this is our baseline. So we run our test and we get our baseline. We have latency at the 99 percentile. That's how you measure latency. You take the 99 percentile of stuff, and then it's 80 milliseconds, and you can do 3,200 requests per second with a throughput of 1.5 megabyte per second. Good, bad, I don't know. It's what it is. Okay, it's our baseline. Okay, with Mercurius, if you're testing with other libraries that support federation, you probably see lower numbers. So probably want to use Mercurius. We are at NearForm overall. One of my teams in the past developed a tool called Clinic, which can be used to create a lot of to create flame graphs and do performance analysis of Node.js. So it's a flame graph of our gateway. It's nice, right? You can see it's a gateway, and as a gateway does, it does a lot of HTTP requests. What is used to do HTTP request? Undici. What is Undici? Is the new library HTTP client that I have been developing as part of my activity in Node.js to implement the new HTTP client for Node. If you have followed the Node.js development, we are releasing Fetch soon, which will be using this stack. Now, Undici uses some WASM internally, and also it has some other stuff in it. So you can see it on the left of this slide of this. Okay, that is a big block of things that come from Undici. That is our HTTP client, right? So and this it's a gateway, right? So if it's a gateway, it's doing a lot of HTTP requests. That's what a gateway does. So it's normal that you're spending a lot of CPU time doing HTTP requests. So how much can we improve this? How can we improve? And the result, it's quite a lot. Just by enabling the caching with no TTL, no time, no spent, we can put it in 4, divided by 4. Okay, we are improving it 4x. We are improving it and bringing it to we are moving maybe 4x the number of requests and 1/4 of the with a 1/4 of the latency. It's impressive. More or less, it's 4x of the amount of even on the throughput. Now, we can even increase the TTL, so the time that the data stays in the cache. Whoa, wait a second. You're saying that you made your HTTP server go 4x. Yes, that's exactly what I am saying. And this is the flame graph to prove it. So after we've done all of those things, this is the flame graph. So you can see that the flame graph is totally different compared from the previous one. All those calls with Unity have been removed. It's not doing an HTTP request anymore, but it was a gateway, right? So, however, something new has appeared. Now the bottleneck is the caching layer, and there is this little library called async cache dedupe that I don't know. Maybe we are going to explain how we did some magic now. Okay, so it's let's talk a little bit of where did the HTTP call go. Okay, first of all, we are going to remove the clones. Okay, we don't want the clones to win, so we need to remove the clones. So we deduplicate. Let's talk a little bit about deduplication. Okay, now you have your event loop. With this event loop, which you are probably familiar with this kind of visualization, right? You have one event, you have processing some JavaScript, then you schedule some IO to happen, then some events come through and you execute one of those events, right? It also means that if you want to make your code fast, you need to, wait a second. If you want to make your code fast, you need to minimize the time in which you execute your JavaScript code. Now, let's imagine that we are receiving a GraphQL query. It's a new event that comes through. It goes into the Node.js C++ layer, and at some point it executes our JavaScript, which then in turn will call our resolvers and do all those things. Okay. Now, and in the end, it will also process all our promises too. Now, what we can do, though, is inside our JavaScript function, when you are invoking our resolver, we could create a deduplication cache. So we can compute for each resolver that we are invoking, we can compute a key and retain the promise that resolver is returning us. So basically, what we can do is have this key and then have a pending promise waiting for it to happen. However, whenever something else comes through that has the same key, essentially, we can take it from the dedupe cache. Now, it will, these exist up until the promise is pending or up until I keep the result. So, and this is what async cache dedupe does. It's a really powerful module that, to be honest, you should all be using today if you're working with Node, but it's a little dark secret, okay, of like dark magic type of stuff. So I don't know if you want to play with magic, but if you want to play with magic, this can really improve the performance of your systems. And you create your cache, define some of your methods, and then pass in arguments, and you automatically have deduplication. So and caching all in one box. So what does deduplication means? It means that if I am invoking the same function with the same arguments in a given amount of time in a given time slot, in fact, you will be keep resolving to you will not invoke you invoke that function only once. What does this mean in practice? If we are reading data from one database, what we are doing is that if two users are resolving the same the data to the same database, we are not issuing twice the queries. We are only issuing the query once and get the data to both users. It's great because it can reduce the strain of our database for most of the very popular content, and most of the application web apps right these days are very skewed towards certain data versus others. So it's great. But we are talking about this. How can we compute a good cache key, right? What does a good cache key comes from? Well, we have. Let's talk a little bit about a resolver. A resolver includes root, that is the current object, args, which are the arguments of that resolver, then the context, which is the Node.js request, response, the database, the HDA authentication of the stuff, and the info, which includes the actual query being computed. So a good argument for a good way to compute a key is to use a stable stringification algorithm. What does it mean? Well, with JSON stringify, if you swap two keys in the object definition, you will get two different objects, two different strings. With a stable stringification algorithm, you will actually get the same keys, even if the object is defined. And well, we have used this. It works great. However, now this library, it's actually the bottleneck of my code. So if you know a better algorithm to generate a key, an hash key from an object, just let me know. And specific for GraphQL, though, we also need to add some more stuff on it. So we need to add the current self object. We need to add the arguments that the resolver is being passed through. But we also want to specify something called the field nodes. The fields, which are the fields being selected, because, if you are selecting the multiple different fields, we want to limit it, and so on. So, in fact, when we call it the 0-second TTL, is just with deduplication. So just making sure that we only call the server once per for each time interval. It just reduces greatly the introduces the latency and improve the throughput. It's great, and it's again, if you increase TTL, you are getting some more improvement, but not so much. The reason of this difference is because the target server is actually very fast. It serves data from memory. If it was going to do a very complex database query, you would have seen a way bigger difference. Well, coming to the end, but I still have a little bit more to talk about. All of this was doing caching in process, but in-process caches are problematic. They can get out of sync between multiple processes, suffer memory leaks, and so on. So the actual good answer here is use Redis. It's always a good answer. Use Redis, right? But the math does not add up, because if we need to store data in Redis, if you have 100 GraphQL, if you have 100 query per second, GraphQL query per second, that each of them invoke 20 resolvers, we will need to do more or less 2,000 Redis get per second. However, Redis is, we need to have at 0.5 milliseconds round trip to the database, including networks. So that does not add up. It doesn't seem a good solution, right? How can we fix this? Because it's not working as we thought it would. Well, that's not true. I have a solution. So essentially, I have invented this technique called auto pipelining. I spoke about it at RedisConf 2021. You can watch the talk. So it's there to watch for you. The idea is that it batches multiple commands in one single Redis pipelines. So basically, it batches all the commands so to limit the round trip time. And this is great, because in that way we can just pay the round trip time once and perform thousands of commands, And the result is, the exact same technique, and that we talked about before. It's the exact same caching, deduplication. It's the exact same event loop technique that we were talking about before. So some real life statistics. We have deployed this into one in production. We have received 100 more requests per second in practice, and we have a 5x expansion factor in Redis. What I mean is for every single GraphQL query, we are doing 15 gets get command on Redis. So whoa, the Redis is not flexing an eye. Well, I'm coming to my talk. As I said, this talk was a bit of a rush, so I just want to finish with a few considerations. As you probably know, there are two hard things in computer science. One is naming things, and the other one is caching validations. So as you know, this is caching. So how do we do caching validations? Well, how can we implement it? And it's supported. It works. It's done. So we just need to implement it. So how do we implement it? Well, what you do is that you need to specify a caching policy, and you need to tell for each one of your resolvers how do you want to do caching, how you want to do invalidation. So first of all, you have a concept of a reference. So whenever you are a resolver is being called, you want to create some references, and what you do is those references, those keys, those are strings, and those strings you will use then later to invalidate those cache. So basically, it's an inverted index for cache entries. Essentially, you specify these references functions, as you said. So the top post is just return a key, top posts. And then we have a get post policy that will specify a reference for get post arg.pid. And then when a mutation happens, you can actually tell the caching layer to invalidate both the get post arg.pid and the post tag. It works beautifully. Okay, so we've done lot of research to kind of 6 months to nail this. So it's probably worth a full talk on its own, but it's that will take 1 hour to explain how all of this works. There's quite a few complex data structures in it. It also supports Redis, so you can have it on memory or on top of Redis. It works very well. However, we also have a companion script of a Redis garbage collector to run, so that there's no memory leaks, but the usage of Redis, some of those data structure will take some time to clean up over time. So you might want to run this garbage collector script to reduce the size of your Redis from time to time to optimize its performance. This being said, thank you for having me. It's been a blast, and please follow me at Matteo Collina on Twitter. And in case you wonder, I work for this company called NearForm. We are hiring all across Europe, North America, and South America. So kind of everywhere at this point. If you are looking to develop stuff with GraphQL, Node.js, React, or you are into DevOps even, or more or less every possible role that you can imagine in tech, please reach out. We have a lot of positions open. So check us out. And yeah, thank you for having me.
Thank you so much, Matteo. That was really insightful. And if you're okay, we'll get into a couple of questions.
Sure thing. Here I am.
So in the example that you gave, really, you sort of differentiated between using an in-memory cache inside the Node.js process, and then you also sort of went a bit into what it would be like and some of the trade-offs when you're using something like Redis, which would be an external cache, but it would be consistent, say, if you have multiple instances of your Node.js runtime. I'm curious to hear, how do you think, because the example that you gave was for a federated GraphQL gateway, which essentially just proxies a lot of the GraphQL requests. How do you approach caching when it comes to working with a database like a relational database or even MongoDB? Because you suddenly have a concern also about some of the pressure on your database, and you might be sort of wondering, is this something that I should solve by adding caching to my GraphQL layer, or is this something that I need to solve on the database layer? So I hope that sort of...
Yes, makes total sense. In fact, we have deployed this in exact same scenario. in front of a MySQL database and a MongoDB database. And the result has been, especially against the MySQL, on top of the MySQL one, has been phenomenal. Because that database was extremely in terms of data, and in terms of some of the queries were actually really complex. So the result was, it was basically suddenly somebody was starting to complain because they were wondering if things were working because the auto scaling was not kicking in on the cloud. So it was just literally, it was the auto scaling was not kicking in, and they were like, what? Why is this happening? Like the database used to scream a lot. They were to over provision significantly. Now the database is mostly idle. It's a completely different new world. Okay, especially if you can cache if you have if we have a subset of queries that is accessed a lot, it's accessed very often, versus very few queries that are also a lot, versus a long tail of queries that are executed less often. So it really depends on your use case pattern. But in my experience, it's you can absolutely use the exact same logic, exact same code, and it will just work exactly the same with the same performance benefits.
Got it. And would your general recommendation to choose either in memory or Redis, or are they ever combined?
No,
No,
I would just in my experience, so the memory one, it's great. However, it can suffer from
inconsistencies across processes.
Yes, exactly. While the Redis one is consistent. So usually you would want to use Redis. That's the TLDR. However, if you can accept a little bit of inconsistencies, especially with very low TTLs, the in-process one is actually great. So if you're putting a TTL of 0 seconds or 1 second or 2 seconds, you can actually use the in-process one and save some money. So you have one less piece of software to maintain. So you can just use the local one and you're good.
I see. So it's really like dependent on the nature of the business sort of logic that you're implementing and how important the consistency. If you're okay with essentially eventual consistency, I guess would be the term here.
Yeah.
Then
exactly.
I see. Thank you so much. We also had a question from Sake Codes who asked, does Fastify and Mercurius replace Apollo server? Yes, it does. Any comments on sort of some of the differences between them besides performance?
Oh, yes, there is one thing. It has built-in data loaders. So if you have been implementing GraphQL and you don't know what data loader is, what a data loader is, you should really check it out. Okay, it's I would say it's almost it's really problematic if you have a GraphQL server and you're not implementing data loaders. Data loaders.
Which one has it built in?
Mercurius.
Okay.
And it's that is one. It also has a few other features in it, so you can have the depth protection, so the max depth protection limit. So you can even say, well, I only want to have, I don't know, 4, 5, 6 queries that have depths of 4, 5, or 6 levels. If you combine this with the data loader patterns, it means that you can put an upper bound to the maximum effort that you can do while doing to the maximum amount of database queries that you can do when solving a GraphQL query, in the sense of you have a maximum D depth, so depth, okay, query. So if you have depth 5, you can assure, if you're using data loaders and you can only have and a max step of 5. You can guarantee that its system guarantees that you're only doing at most 5 queries to the database, and not end up in that n+1 problems that is usually plug most of the GraphQL implementation that I've seen.
Got it. Thank you. And I think you gave a great talk last year, it was, I believe, on GraphQL, and you covered really the n+1 problem. So I'll try to find a link.
Yeah, there is one lurking somewhere on that one. I have a few slides on, I have a few presentation of that. It's great though, but it's very important. So
Matteo, thank you. It's been a pleasure having you here. Is there anything you want to share before you leave? I'm already dropping the link to your newsletter. That's Adventures in Nodeland. So you can, you've probably, our viewers, you've probably seen all of the open source libraries. And in this newsletter, Matteo really dives in and shares on a weekly basis, I believe. You do this, you share your adventures and your perspective on how all of these projects are progressing.
Yep, that's exactly it.
Thank you, Matteo.
Oh, one more thing. NearForm is hiring, okay? Just to be clear, if anybody, and, just to, if anybody wonders, we are hiring, so hey.
So if you want to work with Matteo, this is your chance.
Yay. Bye-bye.
All right. Ciao.